The second and related goal of my lab is to be able to do all this safely. So can we actually provide strong probabilistic guarantees that robots are going to do what we think they're going to do, or that they're going to obey some preset safety constraints so that they don't hurt people, break themselves, even when they've learned these behaviors from just being shown by people. And if we really have these two capabilities, learning from demonstration and safety, we can actually put these robots out in the world, in people's homes and workplaces, and end users can actually program the robots with what they want them to do instead of being programmed by a robotics expert like myself.
All right. You want to go ahead, Robin?
Yeah. Howdy. I'm Robin Murphy. I'm a professor of computer science at Texas A&M. And my PhD is actually in artificial intelligence applied to physically situated agents, which is AI speak for robots. My specialty, though, within this, as you can see, is disaster robots. And you can check out my TED Talk. One of my colleagues in Japan, Satoshi Todokura, and I co-founded the field of disaster robotics back in 1995, and we run the only 2 centers in the world dedicated to using robots and seeing how they can be used for emergency response. I've been in 25 disasters, not of my own making, in 5 countries, and starting with the very first use of a robot, a ground robot for a disaster, which was 9/11, and also including the first use of small unmanned aerial vehicles, which was Hurricane Katrina back in 2005. And you can see UAV there for the Ozo mudslides much more recently. Right now, my students and I and our industry members, as part of our Roboticists Without Borders program, are currently working to help with the Syrian refugee crisis in Europe. We're using the Emily robot, a lifeguard assistant robot. So this is actually it right here. Kind of looks like a very large life raft or buoy. Something you would throw out to them. Well, it is, but it's a robot. It's a miniature jet ski underneath it, and it's been saved at least 26 people's lives that we know from the Hellenic Coast Guard, who has 2 of them now. So, and I think that's a big deal, is to think about robots. They don't replace the lifeguard, and they can assist the lifeguard, and that's what I like about robots the most. So, Dave?
Howdy, I'm also a proud graduate of Texas A&M. Sadly, Robin never taught me anything other than what I've learned from her today, which is quite a bit. She has a great background in robotics. I am the CTO of KUKA Robotics, though I have to confess I am not a lifelong roboticist. I am a lifelong programmer. My interests are actually in the softer side of robotics on a couple of dimensions. One thing I'm really interested in is the diversity of engineering and education for the people that I need to hire to build robotic systems. We were talking in the panel earlier. I think one of the barriers to the ability for us to automate problems in the world is the capacity of the creativity of the engineers that we have. This panel is actually kind of diverse for an engineering panel. We have 2 women and 2 men, which I think is great. This audience is a little less diverse. And so one of my key care-abouts is making sure that we have the right mixture of engineering capability and capacity. That's on the soft side of creating these robotic systems. In practical application, KUKA is over 100 years old and started off making gas lamps in Germany. Through a long history, they've arrived to be one of the world's dominant suppliers of industrial articulated arms, which is not really that sexy anymore. It's basically the arms that sit in a factory and bend, glue, screw metal to make stuff, mostly cars. The robot I have right here is one of my favorite robots. It's a Robogistic robot, which is a logistic mobile platform with a robot arm. We'll talk a little bit about the implications of Robogistics in a bit. So that's a little bit of my background.
All right. And I already told you who I am, and my favorite robot is this strange-looking panda RoboBear. Not because I really know that much about the mechanics of it, but just because I cover healthcare, and the issue of caring for elderly people across the world is one I find fascinating. And this is an attempt to create something that can lift and move patients from their hospital beds up and out of their hospital beds. And while I do not know if it's really very functional, something like this, if you could make it work, would save tens of thousands of people back injuries across the US. This is a huge issue for nurse assistants, every single day. So I'm fascinated by robotics and their capacity to augment rather than replace human functions. So on that note, let's talk a little bit about how KUKA is working to augment rather than to replace human jobs.
Yeah, so I think this specific notion of robots as augmentation versus replacement. I mean, I'm not going to get up here and give a sales pitch that in no way do robotics displace jobs. I mean, absolutely, there is a form of displacement. For me, it's like any other industrial revolution that's happened. Essentially, when you had things like farmers moving into the cities and getting out in front of the regulatory capacity of the cities, you had overcrowding, disease, and so on. And you also had job loss on the farm, which was eventually replaced by the industrial economies that we enjoy today. I actually think we're in the middle of a robotic revolution where we will be displacing jobs, but they'll be reformed at other factors, and that the net benefit to society is for the good. Basically, robotic automation's goal is to improve the quality of life and reduce the cost of production, which is a general good. So a specific example of that is KUKA's groundbreaking in cobotics, or human-robot collaboration, which essentially the way we look at it is unfencing a robot. We mentioned safety standards earlier. Basically, the number of robots that can exist outside of an industrial environment in unstructured ways that are safe to interact with is rather low. So you have to introduce sensing, perceiving, and safety requirements so that you can free the robots to allow them to be everywhere.
Just in case, I don't know if everyone's familiar, this is something that I wasn't familiar with. If you go into a warehouse right now, and the place you see the majority of, correct me if I'm wrong, industrial robots are fenced off away from people.
Yeah, absolutely. I mean, because
they're not allowed to go near people.
One of the ironies that we talked about is the regulatory requirements for having a robot in a manufacturing site are really, really high. And that basically happened because you had strong unions in automotive production. So the amount of requirements that we have to satisfy to have a robot that's fixed, pick up something and move it in a factory is really high. So we might have a multi-ton robot that can break through a wall, and there's all these regulatory requirements. But at the same time, we have all these autonomous vehicles that are now almost unregulated, where you have a multi-ton car driving down a highway at 80 miles per hour with relatively no government regulation. So it's very interesting to me, the difference in regulatory concerns.
Now, Robin, talk a little bit about the idea of, we were talking earlier about anthropomorphizing robots and the desire to have robots like Pepper, robots that tend to look like humans, and to go in that direction. You don't do that in your work in disaster relief. That's not the goal, is to create humans that can go into the mudslides. Exactly. What is the goal of disaster robotics?
Well, I think it's the goal of any good robot is to fit an important niche. And in this case, the idea is that robots are doing things that people and dogs can't do, giving them capabilities. So at 9/11, you're looking at robots the size of a shoebox that can get and crawl in more than 20 feet into the space. Because existing techniques, dog can say a person's there. You can't locate them if they're more than 20 feet underground, even with ground-penetrating radar and stuff. So now you need to be able to get in there. Things that a person physically couldn't do, a dog couldn't get in there while it's still on fire. Things like UAVs, the ability to have aerial vehicles in the air with you on demand versus waiting for 3 days to get it from the USGS, who's done a big overflight, and then they've got to process the data, and then somebody's got to get to you in the field. The ability to do it on demand. What an amazing game changer. And the thing with water. You know, you're not replacing a lifeguard with something like that, but you are saving them the problem of how do we throw it over to them in high seas? How do we get it to there fast enough? How can we run a line to them? You know, we'll shoot a gun with them at it, with, a line at them, which does not work as well as you would think, particularly if you get hit with it. So it's all about designing to meet the need, to amplify, to be the best tool possible, but to be a smart tool, to have the intelligence that where the lifeguard doesn't have to go and drive it like their video game, and that it has enough sense to stop, slow down before it runs into a person, things like that. So it's not just a hammer, it's smart.
So how many of you guys have heard the term deep learning, familiar with what that is? Pretty familiar? All right. Right next to me, I have someone who considers himself a deep learning grump. I'm pretty sure. So explain yourself, Scott.
Wow.
I put him on the spot there.
I'm not sure I would go so far
Oh.
as to say grump, but I guess here's what I'll say about deep learning is that it's hard to be a skeptic of deep learning because we are getting, in our field of machine learning, we're getting state-of-the-art results from deep learning that is allowing us to, do better image understanding, natural language processing. In many, many fields of ML, we're seeing state-of-the-art results coming from this. So, it's hard to be an entirely a skeptic because it is getting results. The place where I would be skeptical is, sort of coming back to the topic of the panel, is that I think there's this, sort of zealotry of the media combined with this really sort of seductive notion that because it's called deep learning or neural networks, that these things are doing something like what the brain's doing, and if they're doing something kind of like what the brain's doing, then we just need slightly better techniques and a little bit faster of a computer, and we're almost at having a robot that is as smart as a human or that can act human, and from a computational point of view, we're nowhere close to being there, and I suppose the other danger I see is just that with so much media attention and money and corporate buyouts and things all being really, really hyper-focused on deep learning now, it can overshadow some other really important things that are going on in artificial intelligence. So, if you're familiar with some of the things that have happened in deep learning in the last couple of years, so for example, AlphaGo beating the world champion at Go, DeepMind's other system that was able to play Atari at superhuman level of performance. These things use deep learning as one part of the system to sort of discover good features and understand the domain hierarchically. But it also built on decades and decades of work in areas like reinforcement learning, of which without which this would have not been possible at all. And when you separate out these different components and put too much emphasis on one, I think it could be a little bit dangerous in that, if something goes underfunded, we're not really going to get major progress toward what we would sort of consider true human-level intelligence.
Okay, fair enough. But what is right now the actual realistic future scenario just in the next few years of deep learning? What can people expect realistically?
I don't think anyone knows. So I mean, I guess the reason I would say that is because if you would have asked me or basically anyone, 4 or 5, let's say 5 years ago, do you think in 5 years that, well, for example, a deep learning system, or didn't even exist back then, but just a learning system would be able to beat the world champion at Go? And a lot of people thought that was still about 20 years off. If you would have asked somebody if you could take an image and generate really high quality natural language captions for images, a relatively high proportion of the time. Most people working in natural language processing and image understanding would have said no. So deep learning was a breakthrough. I think the progress is slowing down a little bit, but that doesn't mean that it's going to keep on slowing down. So I think it's really quite difficult to say where we'll be in 5 years. I think I can speak later, maybe more broadly, about trends that I think are going to happen in especially robotics in the next couple of years, though.
Another term that gets kicked around a lot is cloud robotics. And I'm hoping that you can shine a light on that, David, in terms of what you do with KUKA as well.
Sure. I mean, it's kind of interrelated, frankly, with the deep learning discussion. So, I mean, if you want to have a system for robotics that essentially allows you from as much decentralized compute, which is cloud, why do you want the decentralized compute? It's so that you can take the data that's on the sensors and actuators on the robot and put it into a learning system. So I know we have skeptics on deep learning and its applicability and whether we should be trying to model the human mind or not. But from my point of view, where robotics really is taking the goodies that have been created in the IT industries around deep learning as well as some of the object characterization stuff and really integrating it into the control loop of the robot. So if you look at a robot and you want to say, maybe I want to auto-identify this glass and its location on the table and even identify that it is glass, and then have that inform a control algorithm to say how much pressure should be applied when trying to grip it, what do I need to do to make that work? Sounds pretty simple, but I need a camera that's 3D so I can see and identify a point cloud of the image. I need a connection from the robot that's reliable up to some computing that is in the cloud, so maybe I need some 5G networking. And then I need all that great infrastructure that has this huge database of object identities, so I can that's a glass and do some kind of object characterization and say, oh, that needs this force, and then sort of on the fly figure out how to do the kinematics of moving the arm and picking up the glass. I mean, and all of that technology, which is essentially the standing on the giants of all of these, the technology giants, so that my robot can pick up a glass, which seems pretty basic. So there's the hype and amazingness of what's happening out there with the self-driving cars and all these other things, and I just want to build a robot that can easily pick up an object, which is a really hard problem.
An open problem, in fact.
I think forks are still yet to be conquered. I'm not sure. So, and in terms of, we were talking earlier with Robin about the technical capabilities already existing for disaster robotics, which is different. You're saying it's at a much higher level. The existing robots we have could be serving in many disaster sites, but they're not.
Yeah, that's a personal source of frustration. I mean, the robots have been used consistently since like 2001 for building collapses all over. Those are just basically robots that have been used for sewer inspection and adapted. Bomb squads are using things that came out of the Hurt Locker style of robots. UAVs all over. Do you know that not a single one of the 28 FEMA search and rescue teams are allowed to use UAVs or Emily or any ground robots?
At all?
None of them at all. Because literally for the last 10 years, the government, FEMA, has been trying to create standards, because you can't buy anything on a federal government purchase list unless you have standards for what you're buying. And so everybody's just kind of figuring out, well, it's hard to write standards for new things. I mean, we know from the diffusion of innovation, it takes about 20 years to settle out. So when the early stages of innovation, you want a lot of flexibility so people can get stuff, try it out, see what's really working on. But at the same time, you want to be responsible. You don't want to have accidents or crashes or make a disaster worse. But they're still just taking forever to get it through. So the only groups that are having it are those that, like Austin. The city of Austin's a great example where they have invested, their fire department has invested in robotics, very rationally working with the local community, applying their own internal standards and introducing them into firefighting and rescue work.
So they've been able to do it in Austin?
Yep, but not with any federal or state funding because we're not allowed to. So it's almost unethical. When you're talking about a technology, the listeners just not even say about what you can save in lives. If you can just cut 10 days off of the response time to a hurricane, you can save a couple $2 billion, okay? So an economic loss to that state or states. So it's almost unethical not to do this.
I want to get an image for, you talked about some of the disaster sites you've put robots in over the past decade. There's been many of them. What specifically did you do with the mudslides in Washington State?
So the mudslides in Washington State, everybody's like, oh, you are out looking for people, in the mudslides. It's like, no, that immediate search and rescue for looking for life-saving, that's something that people on the spot were already doing, already trained to do. What they called us in to do was that mudslide. So think of the mudslide, you've got this mountain that's now gone like this. Well, this part here, nobody could get into. It's very hard to fly a manned helicopter. A satellite really can't get angles at that, no matter what it is in the movies. They're pretty much top down, okay? And so they needed a way to see what the river was doing, because that mudslide was forming that. All of the people, by the way, who were doing the rescuers were actually downslope, 7 feet below grade. So if the river had or secondary slide had happened, they would have drowned because they were all working in mud and waders. So there was no way for them to get out. And then you've got everybody else's property and salmon fishing. So the public works people, independently of the search and rescue people, all part of the same group, but they're like, no, we need the UAVs for this. So everybody's like, oh, you can't fly UAVs because you're looking for, what about the privacy? And it's like, no, we're over here by, helping. So people always get hung up on this kind of like robots are going to run in and save the baby from the burning building. No. It's a tool. It's like fire engines don't run in to save babies, but they certainly help the firefighters get in to do stuff. So that's the sort of thing we do.
Let's talk a little bit about money and location and the U.S. robotics industry, which, to get a sense, there are certain pockets of action and of startup fundings, particularly in the Bay Area, in Massachusetts, and maybe here in Austin. I'm not so sure about that. But mostly the US robotics industry is behind. Is that accurate?